Okay, let's review our steps for solving equations. We have this set of moves available to us, right? We have the basic moves that we've had forever. The add, subtract, multiply, divide ones. The only new thing that we've learned about that is that if we accidentally multiply by 0, we might introduce extraneous solutions. We were just talking about if the variable is inside a function, then we use the inverse to remove it. Isolate it, apply the inverse. Depending on how our function is structured, we might get extraneous solutions and we might get multiple solutions. And then we've spent a lot of time talking about if the variable appears more than once, we want it to be a polynomial because then we can factor. And we mentioned something about if it's not a polynomial, can we pretend it's a polynomial? And we haven't done that yet. We haven't met anything that wasn't a polynomial, but we could pretend. That's what we're going to talk about now. What does it look like when we pretend we have a polynomial? So suppose we have this equation. This is not a polynomial because the exponents are fractions. But we see that this exponent is twice this exponent, right? 4/3 is twice 2/3. So we can think of this as x to the 2/3 squared plus 5 x to the 2/3 minus 36 equals 0. So even though this is not a polynomial, well, it's something squared plus something plus a constant. We can pretend that this is quadratic. So we're imagining that this is a quadratic equation in some variable u, but that u happens to be x to the 2/3. We can factor that, thinking about the quadratic. Well, it's quadratic, its leading coefficient is 1. We can use the shortcut. Two numbers whose product is -36 and whose sum is +5. That's +9 and -4. But then instead of u, which is just a variable that we made up, we actually want to say x to the 2/3, which is what we actually have in our equation. So we're pretending this is a polynomial. It's just a polynomial where the variable is x to the 2/3. But now we have this product that's equal to 0. So either x to the 2/3 plus 9 is 0, or x to the 2/3 minus 4 is 0. Well, this one gives us x to the 2/3 is -9. This one gives us x to the 2/3 is 4. Here we have an even numerator, which means this must be positive. So it can't equal -9, so we have no solution here. We cross this one off. Over here, we have x equals, well, 4 to the 3/2. Again, this is even, so we need a plus or minus. We end up with x equals plus or minus 8. So we got two solutions. We could potentially have gotten as many as 4 solutions if we hadn't had to throw this one away. Here we happened to get 2 solutions, and to do that we just had to pretend that we had a quadratic. Let's see another way that we can pretend that we have a polynomial. Here, our exponents are not multiples of each other. Right? There's nothing nice I can multiply 2/3 by to get 5/3, or 5/3 by to get 8/3. However, I notice that all of these have as a factor some power of x. I can factor that out. I can factor out, well, the smallest power of x here is x to the 2/3. And then I'll be left with x to the 8/3 minus 2/3 plus 2x to the 5/3 minus 2/3 minus 8x to the 2/3 minus 2/3 equals 0. So that'll be x to the 2/3 times, well, 8/3 minus 2/3 is 6/3. That's just 2, x squared. 5/3 minus 2/3, that's 3/3. That's just 1. So I've got 2x. And then 2/3 minus 2/3, that's 0. So that x cancels out entirely, and I've just got 8. So here I have this factor, which x to the 2/3, okay. And then I have a polynomial factor, which I can factor further, right? X to the 2/3 times, leading coefficient is 1, so I can use the shortcut. I want two numbers whose product is -8 and whose sum is +2. So x plus 4, x minus 2. So one of my factors is 0. X to the 2/3 might be 0. X plus 4 might be 0. X minus 2 might be 0. If x to the 2/3 is 0, then the only way for that to happen is if x is itself 0. X plus 4 is 0, that's x is -4. X minus 2 is 0, that's x is 2. Now before we say these are solutions, remember, if we have an exponent with an even denominator, then we have an even root in our function. We have to check for extraneous solutions. That didn't happen in this case. So all of these are solutions.